This video is sponsored by Brilliant. Hey, welcome to 12 Tone. Let me ask you a question. What interval is this? Well, these notes are 6 half steps apart, which is 1 half step smaller than a perfect fifth, so the correct term for it would be a diminished fifth. Great, follow-up question. What interval is this? Well, these notes are 6 half steps apart, which is 1 half step larger than a perfect fourth, so the correct term for it would be an augmented fourth. Awesome, thanks for joining me. I'll see you in the next video. Wait, hold up. What's going on here? Alright, so this potential ambiguity, where the same interval can be a fourth or a fifth depending on how we write it down, may seem like a pretty harmless quirk of modern notation, and it kind of is, but it also tells us some pretty neat stuff about the scales we use. First though, we need to look a little deeper at the concept of intervals. We usually say that an interval is the distance between two notes, and that's basically correct, but one thing that often gets left out is how exactly we're doing the measuring. In practice, there's actually two different schools of thought here. Probably the most obvious way is to just count the number of half steps like we did before, so this is 3 half steps, this is 6, and this is 10. This approach gives us what's called the specific interval because it unambiguously describes the exact distance between two notes. But we don't really use specific intervals very often. We don't say things like the melody goes up 3 half steps here. For the most part, we use what are called generic intervals, where instead of describing the distance in half steps, we describe it in scale steps. For example, if we were in A major and we wanted to go from C sharp to E, we'd be skipping over one note from the scale, D, so that makes this interval a third. If we wanted to go from D to F sharp instead, that'd also be a third, even though it's a different number of half steps, because there's still only one scale step, E, in between them. If we really need to describe the difference, we can call the first one a minor third and the second a major third, but my point is that by calling them thirds at all, we're lumping them both into a single category, creating a distinction between these two sounds and other similar intervals, like, say, an augmented second or a diminished fourth. They may sound the same, they may even be the exact same number of half steps, but the context of their use means they're actually different intervals, at least generically speaking. One person who spent a lot of time thinking about intervals like this was a guy named David Rothenberg. Rothenberg was one of the founders of diatonic set theory, a mathematical approach to understanding the behavior of musical scales, and there's a lot to say about his work, but for this video I'm going to focus on just one concept: propriety. To understand this, let's start by looking at a fairly simple scale, the major pentatonic. Here we have 4 different generic intervals. We can go up 1 scale step, which we'll call a second, 2 steps, which we'll call a third, 3 steps, which we'll call a fifth, or 4 steps, which we'll call a sixth. After that, we get back to the octave and the pattern repeats. Note that the specific names I'm using don't really matter. I'm sticking with the standard ones for intervals of these sizes, but that's just for convenience. What's important here is the number of scale steps they represent. Anyway, let's start with our seconds. These are the notes right next to each other, and there seems to be 2 different kinds. This one, which is 2 half steps, and this one, which is 3. Normally, a 3 half step interval would be a minor third, but since there's no notes in between, this one's arguably better viewed as an augmented second. But again, names don't matter here. Categories do. Moving on to our thirds, we see that there are, again, 2 options. Sometimes it goes 4 half steps, sometimes it goes 5. Our fifths are either 7 or 8, and our sixths are either 9 or 10. So what does this all mean? Well, if we look at our list of generic intervals, we see there's no overlap. Every specific interval we could possibly make out of the notes of the major pentatonic scale fits into exactly one generic category. This means that if I play you any 2 notes, you can tell me exactly how many major pentatonic scale steps there are between them. Furthermore, we can see a clear ordering. All our thirds are bigger than all our seconds, all our fifths are bigger than all our thirds, and all our sixths are bigger than all our fifths. This means that not only is there an unambiguous relationship between specific and generic intervals, but also that that relationship is well ordered and makes intuitive sense, which means the major pentatonic is what Rothenberg would call strictly proper. For an example of a scale that doesn't do that, let's take the major pentatonic again and lower these 2 notes a bit. This gives us a scale called hirajoshi, which is a Western derivation of a traditional Japanese tuning scale. Here we actually have 3 different kinds of seconds. There's a 1 half step version, a 2 half step version, and a 4 half step version. Meanwhile, the thirds can be 3, 5, or 6. The fifths can be 6, 7, or 9, and the sixths can be 8, 10, or 11. This has lost us both of our lovely properties from earlier. The interval of 6 half-steps could be either a third or a fifth, and worse, the 4 half-step second is larger than the 3 half-step third, so while we can still connect our specific intervals to generic ones, that connection is largely arbitrary and potentially ambiguous, which makes this scale improper. Although, quick side note, when I say proper or improper, I'm using it as a technical term in line with Rothenberg's definitions. I don't mean it as any sort of value judgment, so when I say Hirajoshi is improper, I don't mean it's not a real scale or even that it's not a good one. I just mean it doesn't have this one property where the specific and generic intervals line up in a convenient way. Honestly, I kinda wish Rothenberg had chosen a different term, cause calling a scale improper sounds real judgy, and I considered using Gerald Balzano's term coherence instead, but Balzano's model is a little more restrictive, so I decided to stick with Rothenberg's. Why? Well, because Rothenberg's version includes a third category, which he just calls proper, where the scale is ambiguous but not contradictory. For a good example of that, we have to turn to a pretty obscure scale called, major. I'm not going to do all the intervals, but as we saw at the beginning, 6 half-steps can be either a fifth, skipping over 3 notes from here to here, or a fourth, skipping 2 notes from here to here. This means it's not strictly proper, because we can't nail down exactly which generic interval 6 half-steps belongs to, but at least we don't have any cases where an interval is larger by one measure but smaller by the other, so it's proper enough. And this is important because strictly proper scales are really rare. They're not too hard to make if you don't use many notes, but as our scales get larger, it becomes almost impossible. In fact, in standard tuning, there's literally no way to make a strictly proper 7-note scale. Every set of 7 notes contains at least one tritone, and tritones are symmetrical, so if you have one, you actually have 2, and with exactly 5 other notes to distribute, there's no way to get the same number of scale degrees on either side, so all tritones are ambiguous in 7-note scales. However, you can make some scales that are at least not improper. If we don't care which note we start on, there are 5 proper 7-note scales. The major scale, which we already saw, and then harmonic minor, melodic minor, and then this one, and this one, which are called harmonic major and Neapolitan major respectively, and if you want to know more about them, I've done videos on both, links in the description. Actually, there's 2 more proper 7-note scales, this one and this one, but these are what set theorists call inversions, which means they're just like our other scales, but upside down. This one's the interval pattern from harmonic minor, but going the opposite way, and this one's the same for harmonic major, so they don't really count. Anyway, this starts to get at why propriety might actually mean something. Major, harmonic minor, and melodic minor are without a doubt the 3 most important scales in Western music, so the fact that they happen to represent the majority of all, quote, proper 7-note scales implies something. What it implies is up for debate and depends on how much you value those particular scales, but one of the points of diatonic set theory is to provide a way of thinking about scale relationships without being bound to the harmonic series, so being able to derive some of our most common scales in a completely unrelated way is pretty convenient. If nothing else, it means we can take this approach and apply it to other tuning systems, giving us a helpful criterion for determining which scales in that system are most comparable to major. And there's one last point I want to make here. Even among improper scales, you can have things that are more or less balanced. Like, take Hirajoshi. Some of the seconds were bigger than thirds, but it still worked okay as a scale. If you think about it though, it wouldn't be too hard to come up with something with seconds that are bigger than sixths, which is a much larger problem. So maybe a better approach would be to count not just the number of discrepancies, but how far apart the generic intervals are, giving us a whole spectrum of properness that better captures the underlying structure of the scale. At least, that's how I like to think of it. Anyway, despite the name, diatonic set theory is actually more akin to the mathematical field of group theory, and if you want to know more about that, I'd recommend this video's sponsor, Brilliant. They have an entire course on group theory, starting with simple symmetries and working up to more advanced ideas like isomorphisms, with a brief stop along the way to talk about everyone's favorite toy from the 1980s, the Rubik's Cube. The great thing about Brilliant, though, is that they don't just explain things. They give you problems to solve so you can apply the concepts yourself. Hands-on learning is a really effective way to make sure you really understand what you're doing, and Brilliant has courses in all sorts of topics like science, math, and logic, so if you want to learn this stuff, there's no better place. Plus, honestly, it's just fun. So if you want to develop your skills or learn more about Brilliant, you can go to brilliant.org/12tone and sign up for free. Plus, the first 200 people to click that link will get 20% off their already cheap annual premium subscription, and you'll be helping support 12tone along the way. And hey, thanks for watching, and thanks to our Patreon patrons for supporting us and making these videos possible. If you want to help out and get some sweet perks like sneak peeks of upcoming episodes, there's a link to our Patreon on screen now. You can also join our mailing list to find out about new episodes, like, share, comment, subscribe, and above all, keep on rockin'.